Okay, well, here we go on another night of rational expressions. We're on to section 6.3, where we're going to be talking about complex rational expressions. Complex rational expressions, meaning more difficult, usually complex means. And in this case, complex is more difficult. But technically what it means is a fraction within a fraction. So a complex rational expression is a rational expression that has another rational expression either in its numerator, in its denominator, or in both the numerator and denominator. So you can see here's an example of a complex rational expression. Not only is it a rational expression, but it's a complex rational expression. You can see two different fraction bars. And here on this example, here's our main fraction bar. But then in the numerator of the fraction, we have a fraction. And in the denominator of the fraction, we have a fraction. This is a very complex rational expression. Fractions within fractions. Here's another example. Here's our main fraction bar. Here's the numerator of our fraction, here's the denominator of our fraction. Both the numerator and the denominator have fractions. So we have fractions within fractions. And this one over here is a little bit different, but this is a complex rational expression. It's complex because any number raised to a negative exponent is 1 over that number. Now, the trick is people want to take this and put it to the bottom, but you can't do that because of the plus sign right there. If it was a to the negative 1 times b to the negative 1, where both a and b were factors of the numerator, then yes, you can take the factor raised to a negative exponent and put it to the bottom. But because it's part of the binomial, instead the way we think about this is a to the negative 1 is 1 over a, b to the negative 1, that should say 1 over b, and then I have my main fraction bar. There's my main fraction bar, here's my main fraction bar, and then a to the negative 3 is 1 over a to the third, and then here we have times, so if I could reduce to the top I would, but I can't. And so this is times b to the positive third. Now you can see more likely that this is a complex rational expression. My numerator has fractions, my denominator has fractions. So if you didn't like fractions and you started feeling comfortable with it in the last two sections, well, here's another opportunity for you to get more comfortable and confident with it. So let's keep that growth going. Alright, let's see what are we going to do with these complex rational expressions. Well, believe it or not, rational expressions can be simplified. You know, when you take a test and the directions say simplify, if possible, that's the type of directions you'll see on a problem like this. Simplify. And so here's how we simplify a complex rational expression. So here is our complex rational expression. Here's our main fraction bar. My numerator has a fraction here. My denominator has a fraction there. So I have a complex rational expression. And you're not allowed to leave, and this is key, you're not allowed to leave fractions within fractions as your final answer. It is not considered simplified. So you will never receive full credit if your final answer has a fraction within a fraction. If your final answer is a complex rational expression, it will not be full credit. So let's talk about how we can go ahead and simplify a complex rational expression. Well, in order to simplify a complex rational expression, method 1 is to find the least common denominator of all the denominators. So my numerator has a fraction, it has a denominator of 2. My denominator has a fraction, it has a denominator of 7. So I'm looking for the LCD between 2 and 7. Now the LCD is also known as the least common multiple, so the multiples of 2 and the multiples of 7 that match up is my least common denominator. So in this case, the least common denominator is 14. So find the least common denominator, then multiply the numerator and the denominator by the least common denominator. So I'm multiplying by 1. This is just a version of 1, right? 14 over 14 is 1. But I'm going to multiply it into my numerator, and I'm also going to multiply it into my denominator. So for the numerator, 14 times y, I just get 14y. and then the plus sign comes over as plus. And then I have to do 14 times 1/2. Oh, 14 times 1/2, that's 7. Alright, good. Notice now my numerator has no more fractions. Here's my main fraction bar, and now I'm going to the bottom. 14 times y, let's go to green, 14y, and then minus, bring that minus sign over, and then 14 times 1/7, let's see, 14 times 1/7, that can be reduced to 2 over 1, so that equals 2. And now my complex rational expression has turned into simply a rational expression. There's only one fraction. And this would be considered mostly simplified. You could consider factoring out the 7 and be left with 2y plus 1, and on the bottom factoring out the 2, and you're left with 7y minus 1. Either one of these is as correct as the other. However, in factored form, it is easier to identify whether or not something can be reduced top to bottom. Here, nothing can be reduced. Over here, you're not so sure. So I do recommend you factor it out and then look to see if anything reduces. This is the best final answer in factored form, but this one is not wrong. There is another method of simplifying a complex rational expression, and that is to simply simplify the numerator and the denominator separately, then treat the result as a division problem. And what I mean by that is, let's just simplify this, y plus 1/2. Let's turn it into just one fraction. So right now I have y plus 1/2. The denominator of this y is a 1. The denominator of this 1/2 is a 2. So I need to multiply this by 2 over 2. And now I get 2y over 2 plus 1/2. I have the common denominator. And so because I have a common denominator, I can write it over that denominator. So this becomes 2y plus 1 over 1/2. I do the same thing down here. Let's go with that green again. So y minus 1/7. Let me simplify y minus 1/7. Right now y is over 1, so I need to multiply that by 7 over 7. I get 7y over 7 minus 1 over 7, and that gives me 7y minus 1 over 7. So we're dealing with the same problem, but I'm showing you a different technique. And this technique is, hey, let's just take the numerator and write it as one fraction, with the common denominator. Hey, let's just take that denominator and let's write it as one fraction with a common denominator. Now, I know I boxed those, but those aren't my final answers, so let me undo those boxes. So now I take this numerator, which is 2y plus 1 over 2, and then I divide it by my denominator, which is 7y minus 1 over 7. Now, I talked the other day in section 6.2 about dividing fractions. Instead of dividing by a fraction, we should think of it as multiplying by the reciprocal. So instead of dividing, I'm going to do times. So this division has just turned into times here. But now instead of dividing by 7y minus 1 over 7, I'm going to multiply by 7 over 7y minus 1. Now here I have two fractions being multiplied together. So I multiply the numerator, 7 times 2y plus 1, and I multiply the denominators, 2 times 7y. Here, let's try that. 2 times 7y minus 1. And when you compare the answer from this method to the answer of the other method, you'll see that they are exactly the same as each other. There's that one. There's this one. Those are exactly the same. I don't care which one you do. So you decide which one you thought was best. So here's an example. 2 minus 3 over a divided by 5 plus 1 over a. Here the denominator is a. Here the denominator is a. The LCD is a. So what you're going to do is you're going to multiply this by a, and then you're going to multiply this by a and see what you get. Put me on pause, distribute that a, and see what your final simplified form looks like. Okay, so I distributed the a to the 2, I got 2a. I distributed the a to the 3 over a, those a's canceled, and I was just left with the minus 3. I did the same thing to the bottom, 5 times a. Here the a's cancel. I'm just left with plus 1. My final answer, since nothing can be factored out, is 2a minus 3 over the quantity 5a plus 1. Very good. Alright, now coming over here, in my numerator I have a y and a z. In my denominator I have a y and a z. So my LCD is, very good, y over z. So I'm going to multiply this by yz. I'm going to multiply this by yz. And I'm going to distribute this over to here. Now I'm going to keep you with me while I go through this one just so you can see the work. Okay, yz times 2 over y becomes 2yz over y, and those y's are going to cancel out. And then plus, and then yz times 5 over z becomes 5yz over z, and yes, those z's are going to cancel out, but I'll do that in my next step. Now I'm going to do the yz times 1 over y, and that's going to get me yz over y, and those y's are going to cancel out, and then minus, and then I'm going to take the yz times 4 over z, and that gets me 4yz over z, and yes, those z's are going to cancel out. So let's clean this up a little bit. So the y's cancel out, and I have 2z, bring the plus sign. The z's cancel out, I have 5y. Whoa. There we go. Divided by, and let's see what happens here. The y's cancel out, and I'm left with z minus 4y. Now this is done. That's simplified. The z's can't cancel because of this addition sign and subtraction sign. 2z is not a factor of the polynomial. 2z is a term, and so none of these are factors, so except for the whole thing, and the whole thing doesn't reduce. So we're done right here. That would be a final product for problem number 2. Alright, here is number 3. We're kicking it up a notch in the difficulty level, so let's see how it goes. Let's look at this problem here. I have a denominator. Well, here, first identify where the main fraction is. Where's the main fraction? Here's the main fraction. Okay, so now if I look at my numerator, there's a denominator in my numerator. Here's a denominator in my denominator. So I need to find the LCD between 4c plus 4, which by the way factored is 4 times c plus 1, and c plus 1. Those are my two denominators. So the least common denominator, well, this one just needs a 4 in order to be the same. So the least common denominator is 4 times c plus 1. So I'm going to go ahead and multiply 4 times c plus 1 to the top, 4 times c plus 1 to the bottom, and then I'll distribute and reduce. And you know, if you really truly find the LCD, the reducing should become simple. Like notice here, this and this reduce, and I'm simply left with c squared minus 1. Here the c plus 1 and the c plus 1 will reduce, and I'm left with 4 times c minus 1. Now this might be done, except c squared minus 1 is a perfect square. That's c plus 1, c minus 1, and down here I have 4 times c minus 1. C minus 1's cancel, and so therefore my final answer is going to be c plus 1 over 4. Okay, so don't let the fact that the denominators are polynomials, we should still be able to find the least common denominator of those, even when they're polynomials. So like check this one out, and we got about a minute left before we're going to be done with this video, and I think we're going to have to continue on to the next one. Yeah, there's still another type of problem that I need you to be able to see. So first, see if you can identify the least common denominator. Take a minute, identify the least common denominator of the denominators, and then check back in with me. Okay, so I found the least common denominator to be a plus b times a minus b times a minus b. You can see up here a squared minus b squared was a plus b times a minus b, and the denominator down here was a minus b. So this one was missing one of the a minus b's, so that's what it needs. This one was missing one of the a plus b's, so that's what it needs. So altogether it needs a plus b times a minus b quantities squared as the least common denominator. So here's your challenge. Multiply this by the least common denominator,